This is dig into the attack surface of PDF and gain 100 plus CVEs in 1 year. One of today's last briefings. I hope you enjoy the talk. Firstly, let me introduce myself briefly. My name is Ke Liu, and I'm from Beijing, China. Currently, I'm working as a security researcher of Tencent Xuanwu Lab. And my work mainly focuses on file format fuzzing, such as PDF and images. And you can contact me on Twitter if you have any questions about this talk. A quick agenda about what I'm going to talk about. I'm going to talk about why I choose PDF as my target of my research, and then I'm going to talk about how to find the attack surface and how to get more test cases. Also, I'll talk about some fuzzing tricks which could make fuzzers more efficient. And finally, I'll show you the statistical results of my research. PDF has become a de facto global standard for more secure and dependent information exchange. I think everybody in this room is familiar with PDF. There are already some talks about PDF security, such as Nicholas's dump fuzzing XSLT engines in a smart way, and ZDI's abusing Adobe Reader's JavaScript APIs, and so on. However, each of these talks only covers a single attack surface, and since PDF is a complex format, there are a lot of work can be done here. This slide shows how complex the PDF can be. First of all, the official standard specification has more than 700 pages, and the JavaScript reference also has more than 700 pages, and the XFA specification has even more than 1,500 pages. Also, PDF supports embedding external file formats. For example, fonts such as TrueType font, and Type 0, Type 1, Type 3, and so on. And also images such as JPEG 2000, JPEG, PNG, BMP, TIFF, GIF, and so on. Also, PDF supports other features such as XSLT, which stands for Extensible Stylesheet Language for Transformations. My research started since December 2015, and more than 120 vulnerabilities have been patched by vendors. So now let's talk about how to find the attack surface. I summarized 4 methods here. The first one is read the standard documents. You don't have to read all thousands of pages here. Just read the parts that you are interested. The second one is investigate the installation files. I'll talk about it later and use Adobe Reader as an example here. The third one is investigate open source projects. Also, I'll talk about it and use PDF IOM as an example. And the first one is watch the security advisories, such as APSB, which stands for the Adobe Product Security Bulletin, and ZDI's Security Advisory, and Chromium's security issues. And for time reasons, I'll just talk about the second and the third methods here. For installation files investigation, here I use Adobe Acrobat and Reader as an example. So to figure out a file's functionality, we can focus on the following information, such as file name, properties, strings, including ASCII strings and Unicode strings, and function names, including internal symbols and export functions. also copyright information, and so on. So here, let's take the jp2klib.dir file, for example. We can find this file in Adobe Acrobat and Reader's installation directory, and take a look at the property page of this file. We can easily figure out that this file is responsible for freezing JPEG 2000 images. And this table shows the functionality of some of the files in Adobe Reader's installation directory, including core library, color engine, XSLT engine, font engine, and so on. And this table shows the functionality of some of the plugin files in Adobe Acrobat and Reader's installation directory, including Forms plugin, Annotation plugin, JavaScript plugin, and image conversion plugin, and so on. And it should be noted that the image conversion plugin is only available for Acrobat Pro DC. The standard Acrobat Reader DC did not have this file. So we can also find the attack surface from open source projects. For example, the PDF IOM is a famous PDF rendering engine and is open source. And this project is maintained by the Google Chrome project. It is the rendering engine of Chrome browser. So we can try to analyze the source code to find more attack surface. But here for PDF IOM itself, it ships nearly 20 official folders. So we can find the folders under the testing libfolder directory. The folders cover the following fields, including XML, font, images, engines, and forms. Now you don't have to read the boring standard documents. You can just analyze the source code of the libfolder components here. Now let's move to the next topic, how to get more test cases. Test cases play an important role in the fuzzing process because more test cases mean more possible code coverages, and more code coverages mean more possible crashes. Then the question here is how to get more test cases. Writing a crawler is acceptable in most cases, but I'll show you some alternative ways. So firstly, let's talk about the strategies for modern fuzzers, such as AFL and libfuzzer. For AFL, a single and small test case is enough, and for libfuzzer, a minimized set of test cases is acceptable. But libfuzzer could still work even without any initial test cases. The thing I want to point out here is that these two fuzzers will generate lots of test cases during the fuzzing process. So why not reuse the test cases that was generated by the two fuzzers? Firstly, we can fuzz open source libraries or similar open source libraries with AFL and libfuzzer. Then we can test binaries with the test cases generated by in the previous steps. So our goal here is to find an open source version of the target library, or at least find a similar one. Alternatively, we can get help from open source projects. Because popular project also maintains a test case repository which contains lots of valid and invalid files. This table shows us how to find PDF documents, JPEG 2000 images, TIFF images, and TTF fonts. If you want to find some samples of JPEG 2000 images. You may not able to get lots of samples from search engines, but you can get about 200 ones from the OpenJPEG's repository. So now let's move to the next topic, fuzzing tricks. The first one is write PDF makers. Generally speaking, PDF is made up of plain text and battery data. To make our fuzzers more efficient, we should only mutate the part that we are interested. So a possible solution is to write a PDF maker which could translate a specific file to a PDF. For example, if you want to fuzz the JPEG 2000 rendering engine, you can translate the JPEG 2000 images to a PDF file. Then you can test the PDF file with the target PDF reader. Then the question here is how to write a PDF maker. Well, we can use third-party PDF makers or libraries, but there is a problem because I think this method is not flexible since the third-party PDF makers and the libraries they has error checking functionality. This functionality may lose lots of test cases. They are rejected to translate a morphed or invalid file to a PDF file. So I recommend that you should read the standard documents and write your own PDF makers. The second one is fuzz third-party libraries. First of all, we should check if the target uses open source libraries. If so, we can fuzz the library with AFL or libfuzzer because this can be more efficient. Also, the target may be affected by old vulnerabilities, and zero-day vulnerabilities could affect all targets that use the library. Here, I use libtiff as an example. Last year, I discovered an out-of-bounds write vulnerability in libtiff's pixel log decode function. It should be noted that this vulnerability was also discovered by some other researchers, but it's a zero-day vulnerability at that time. This table shows the software that was affected by this vulnerability. And in this case, we can see that Adobe Acrobat's image conversion plugin, Chrome Dev and Beta with XFA enabled, and Foxit Reader's rendering engine and the Convert to PDF plugin were all affected. But it should be noted that the Adobe Acrobat and the Reader's rendering engine was not affected. It is because the TIFF's image's pixel log compression was not supported. And we can verify this condition by reversing the acrophone.api file, and we can find such a string that indicate the compression algorithm was not supported by default. Now let's talk about another trick. Why bother fuzzing PDF readers and browsers? Readers and browsers are huge software. Create instances of such products are time-consuming because the process will load lots of unnecessary libraries and do lots of unnecessary initializations. Also, GUI is unnecessary under some circumstances. Our goal here is to not initialize and execute unnecessary code as less as possible. So let's just focus on what we are interested in, and we can write wrappers to achieve this goal. So when can we write wrappers? If the product meets one of the following requirements, we can write wrappers easily. Firstly, the target is open source, such as PDF-IOM. Secondly, the target has SDK, such as Foxit Reader. but it should be noted that here the Foxit Reader's SDK seems always outdated. Certainly, the target has APIs such as Windows PDF library, and we'll talk about it later. Finally, we have to do some reverse engineering work to find a proper function if the product doesn't meet all the mentioned requirements here. So let's take Windows PDF library as an example. Windows.data.pdf.dll is a core module of this library. Microsoft ships it since Windows 8.1, and the library can be interacted through Windows runtime APIs. So here, if we want to render a PDF file, we can call in the node from string async interface of IPDF document statics, and then we can get a page of the PDF file by calling the getPage interface of the IPDF document, and then we can render the page by calling the prepare page async and the render to string async interfaces of the IPDF page. And again, for time reasons, we are not going to talk about the details here. But if you are interested in how to write a PDF wrapper, and you can read my white paper, it will tell you how to get a copy of the code. So, my research started since December 2015, and during the research, I reported more than 100 vulnerabilities to Windows, and 122 of them have been patched. And there are some unpatched ones on the way. My research covers Adobe Acrobat and Reader, Adobe Digital Editions, and Foxit Reader and Edge Browser, which was implemented by the Windows PDF library, and the Chrome browser, which is the PDF IOM, and I also first the Mac OS preview. And it should be noted that my research mainly focused on Adobe Acrobat and Reader. This figure shows the vulnerability distribution sorted by vendor. Again, it should be noted that my research mainly focused on Adobe Acrobat and Reader. Here, one CVE for each vulnerability, and bug conditions are excluded. And vulnerabilities that only affect the beta or dev versions of products are excluded, and the unpatched ones are excluded. And the result here is just for reference. It does not mean which product is more vulnerable than others. And this figure shows the vulnerability distribution sorted by attack surface. Here, the pillars stand for the PDF converter, the JPEG 2000 images, the XFA component, and the rendering engine, the font engine, and some other attack surface. Here, a short story about Google Chrome. And last year, I found that XFA was enabled in Chrome Canary, dev, and beta versions. So I started to fuzz the XFA component in PDF IOM and reported dozens of vulnerabilities. And soon, the official developers noticed that this component is full of bugs, and they wrote some fuzzers themselves. And they use the class fuzzer to run the fuzzers, and they also found some vulnerabilities. So since the component is full of bugs, they soon disabled the XFA component 1 month later. And the XFA component is still in active development and disabled in Chrome browser. And this is the final slide. I hope you can connect the following takeaways from this talk. Firstly, know the attack surface of PDF and methods to find it. Secondly, learn to connect test cases from open source projects and modern fuzzers. And finally, learn some fuzzing tricks to make your fuzzer more efficient. Okay, thank you all for listening. And please feel free to ask me if you have any questions. Okay.
Have you tried any of the mobile PDF viewers?
Okay, this friend asks if I trying to test any mobile apps, mobile PDF readers. And my answer is I didn't do any investigations to the PDF, mobile PDF readers, and I know that many of the readers are written in Java language, and so it's hard to find the memory vulnerabilities using my fuzzers. So I did not investigate them. Okay, any other questions? We still have time. Okay, if